Alright, what up everyone? This is LeetCode 21 merge two sorted lists. So this one's in C++. I've done this problem before in Python, so if you're looking for a Python solution, it should be on my channel. Same title and all, but obviously you have to type in Python, you'll find the video. So in this problem we have two sorted linked lists, list 1 and list 2, and we have to merge them into one sorted linked list. So the way we do that is we just use pointers, right? So we put a pointer at the head of linked list 1, at the head of linked list 2, and we traverse through these lists. Okay, so compare 1 and 1, they're the same, right? So just take list 2. So if they're the same, we're just going to take, if we have two nodes that are the same value, we're just going to take the node from list 2 and plug that into the input. Okay, it really doesn't matter, but as long as you're consistent, right? Inconsistent in what linked list you take from to put into the merge list when you have two nodes with the same values. We're just going to take from list 2. So when we have 1 and 1 here, we're going to use the node from list 2, plug that in here, right? Move the pointer over to this 3, compare 1 and 3. 1 is less than 3, so put that into here, move the pointer over, compare 2 and 3, 2, right? Then compare 4 and 3, and etc. You get the point, right? So yeah, it's kind of a, I mean, it is a difficult problem if you're new to LeetCode, but it's not a difficult problem if you get more practice. So the way we're going to do this is we're going to use a dummy node first. Okay, we're going to create a dummy node first. Okay. The point of a dummy node is that, well, I'll explain later. Well, actually, I can explain now. So I'm going to explain what we're doing here. So we're going to create a dummy node, right? We'll call this node here D. And we have a tail here, which is essentially the same node, right? It's essentially the same node, and we're going to use this tail. It's basically a pointer, right? And we're going to use that to traverse through the list and add stuff to it. Okay, add all the nodes that we need to merge a list. Okay, and then when we're done, we return dummy.next, and we'll return the head of the merge list. Okay, that's the point. So tail is basically a pointer to traverse and add to our merge list, and dummy node is just useful to return the head of the merge list by doing return, dummy node.next. Okay, well, not .next, we're not in Python, but the little arrow symbol. So yeah. So we're gonna check if list 1 and list 2 have something, or they both should have something, right? Because if we're doing the comparison, they both have to have an actual node available for us to check. Okay, so if list 1 dot val is less than list 2 dot val, right, that'd be the case where we would want to add list 1 to tail.next and move the pointer over. So we're going to say list 1 is equal to list 1 next. Okay, now if we hit this else statement, that would be a time where these two nodes are equal, or where list 2 is actually the lower value when we compare it to list 1. So in that case, we do tail.next. Well, I keep saying .next, but we're not like literally doing a dot. But you get what I mean. Tail. I'll just refer to it as tail.next, but hopefully you understand what I mean. Syntax is a little bit different in C++, obviously. So, and here we're gonna move the point over for list 2. So we're gonna say list 2 is equal to list 2 next. Okay. Now, when we exit this if or this else, of course, we need to move the tail over because we need to keep traversing, right? So tail is equal to tail.next. Okay. Now, when we exit this while loop, okay, we need to check if list 1 or list 2 still has something. And if it does, we can just add it to the end of the merge list. Because let's say this second list here had like 10 more nodes. When we add this 4 here, we don't have to check all these nodes here, we don't have to check it against anything. So just take the entire thing and plug it into the end of my merge list. That's basically what we're doing. Okay, so if list 1 has something, right, in that case, we would just say tail next is equal to list 1. Else, we're going to say tail.next equal to list 2. Whoops, up here should be list 1, not list 2. It's a typo. Okay, and then when we do that, we're done. So we're going to return the dummy node.next, which should give us the head of the merged linked list, right? Oh, sorry, not dot. This is not Python. Sheesh. Okay. Now, in case you are confused, I'm going to run through an example, okay, of what my code is doing. So we'll just use example 1, okay? So we create a dummy node, right? You can't see the dummy node, right? Well, in this illustration. And then we use a tail node, okay? And we create a tail node that's equal to the dummy node. So while list 1 and list 2, well, they both have something, right? So we enter the while. Is list 1 less than list 2? No, it's not, because they're the same value, right? So just add to the tail. Add the node from list 2 to the tail. So we add tail.next. So we go to this here, and we add this 1. Again, the dummy node's like right here, but technically you can't see it in the illustration. So yeah, tail.next we would add this 1, move the pointer over to this 3. Okay. We're still in the while loop. So 1 is less than 3, add the 1 with a pointer over. 2 is less than 3, add 2 with a pointer over. 4. 3 is less than 4, add the 3, move the pointer over. These are the same values, so we add the 4. Well, technically in our example, I think we would add this 4, but it doesn't really matter. Because if they're the same value, we're just adding the node from list 2, but it doesn't matter because the order really doesn't matter in those cases, because they'd both be 4, right? But it still gives us the same answer, even though they're technically adding the node from list 1 here. We're adding the node from list 2 here, and then we're adding the rest of list 1, because we go here, right? Because when our pointers are here, right, and the other pointers here, right, we check list 1. Is list 1 less than list 2? No, they're the same. So add tail.next, add list 2. So we add this, and we move the pointer over to here. Okay. Now, while list 1 is true, and list 2 is not true though. So we would exit this while loop. While list 1, yes, because we have this 4 here left over, right? So we do tail.next, and we just add this into our merge linked list. And then after that, we exit, return dummy node.next. So we'd return this node here, which would be the head node of the linked list, the merged linked list. And yeah, that'd be our problem, or that'd be our solution. But yeah, like, since these values are the same, it doesn't, I mean, they're color coded, but really they're the same, right? Because all we care about is the values in terms of quote unquote, the merged list being sorted. Because technically these are, if these are two different linked lists, which they are because they're inputs, technically these two nodes aren't actually identical because they're like objects, right? So in theory, they're not technically the same. Meaning if this purple 4 was here and this red 4 was here, in theory they're not actually the same. But we don't care about like sorting by like value and color or something weird like that. All we care about is the values, so it doesn't really matter. But no, I just pointed that out. I just found it kind of interesting because you can overanalyze it if you want, but I don't know, kind of pointless to point that out, but I don't know, maybe you find it interesting. Anyways, yeah, that's this problem, and yeah, I hope to help, and I'll see you in the next one.